Hello friends, today I'm going to solve LeetCode problem number 263, ugly number. In this problem we are given an integer n and we need to find out if the number is ugly or not. An ugly number is a positive integer whose prime factors are limited to 2, 3 and 5. So for n, the value could range from negative to positive, right? And here we are given that ugly number is only positive, so from this we know that if the number is negative we are going to return a false. If it is positive we are going to see if the prime factors are only limited to 2, 3 and 5. If yes, then we are going to return a true, else we are going to return a false. Now, how could we see if the prime factor of an integer is limited to only 2, 3 and 5? Okay, let me just explain you here. So suppose we have a number 6. We know 6, the prime factors of 6 are 2 and 3. We also know that uh, talking about those factors, 6 and 1 is also a factor of 6, right? But 6 is not prime, neither is 1. For any number to be prime, the number should only be divisible by 1 and itself. So 2 is only divisible by 1 and 2, 3 is only divisible by 1 and 3. And in case of 1 is only divisible by 1, right? So it is only a single value. So for any number to be prime, it should be divisible by 1 and itself, which is a total of two different numbers. So that is why 1 is not a prime, 2 and 3 are prime. And in case of 6, we know 6 is not a prime because it is divisible by itself by 1, by 2 and a 3, which is equals to total number of 4 factors, right? Now so how could we find the factors? How could we see if the prime factors of 6 are limited to 2, 3 and 5 only? It should not be and, it is an or. Basically it should be limited to 2. It is either 2 or 3 or 5 only and nothing else. So what we are gonna do here is, we know 6 is divisible by 2, so we see if the remainder is equals to 0. If it is equals to 0, which means that we could divide 6 by 2, right? So when we divide 6 by 2, it returns some value which is equals to 3 here, which is equals to 3. Now 3 is no more divisible by 2, right? Because the remainder is not equals to 2. So next what we do is we try to see, is it divisible by 3? Yes, it is divisible by 3. So next in turn we divide 3 by 3, which means the number n by 3, and then the value we've found was 1. Now 1 is not divisible by 2, 1 is not divisible by 3, 1 is neither divisible by 5. But from this example we could see that 1 is a prime. 1 is an ugly number because its factors are limited to 2, 3 and 5 only. So since we encountered a value 1, in our next step, that is when we will return a true. So we are going to return a true when the value is equals to 1. Else we are just gonna return false. Now let's see in case of another numbers, a big number. Suppose it's 40. We know 40 is divisible by 2, right? So what we do is we divide 40, the new value becomes equals to 20. Again 20 is divisible by 2, the new value becomes equals to 10. Again the new value becomes equals to 5, since 10 is also divisible by 2. So we keep on dividing by 2 as long as it's not divisible by 2, which means that one of the factors itself is 2. So far we found one of the factors, which is 2. Next value we found is 5, which is not divisible by 2. We try dividing it by 3, and then we see that it's not divisible by 3 as well, because the remainder is not equals to 0. So next we try dividing it by 5. It's divisible by 5, right? So the final, when we divide it by 5, we get the value 1, and since the value 1 is an ugly number, so we return a true. So ultimately we are going to return true if the value is equals to 1. If not, we are going to return a false. Let's try to code this value. So since we only ugly numbers are only positive integers, we are going to return false if any value is less than or equals to 0. 0 is also not a prime number. Why? Because any value 0 divided by 2 is also equals to 0. 0 divided by 3 is also equals to 0. 0 divided by 5 is also equals to 0, and 0 divided by 7, which is a prime number, 7 is a prime number, is also equals to 0. So basically 0 has infinite factors, so which means that 0 also has factors, prime factors, not limited to 2, 3 and 4, through 2, 3 and 5. So that is why 0 is not an ugly number. So if we found 0 or negative number, we are going to return false because it's not an ugly number. Else what are we going to do is while n is divisible by 2, we are going to update n equals to n divided by 2. Also while n is divisible by 3, update n equals to n divided by 3. Again while n is divisible by 5, we are gonna update n. Okay, so basically I can do this operator here equals to 2, and finally we are going to return true if n equals to 1, right? If n is equals to 1, we are going to return true, else we are going to return a false. Let's run our code. Great, let's try multiple test cases. Let's add one from our side as well. And some random value. Okay, so the time complexity, why did that happen? Let me just check for only these. Okay, what's happening? If n is less than equals to 0, I'm gonna return false right here. So what's causing the problem? Okay, I need this thing here. Great, let's submit the solution.